Hi guys, so I just wanted to review a couple things with you before we have a quiz over exponential functions tomorrow. Remember, this is the general form right here for our exponential functions. Where A, remember our A there is our y-intercept. Anytime we have that value, we can assume that's our starting point or our y-intercept. Our B is what we would call our common, excuse my lovely handwriting, common ratio. So that's what we go up by. Oh, that A was good. Go up by every single time. So that's what we would multiply by if we were given a table. That's what we would multiply to the value every single time to get a new one. Remember, this is growth. It's getting bigger, where our B value is greater than 1. For example, if we had an equation like 2 times 1.3x, where our B is greater than 1. If B, this is decay. Decay means getting smaller if the B is between 0 and 1, so it's a fraction. For example, if this was 2 times 0.8 to the x power, that would be a growth or a decay of 2%. So here we have a function, f of x equals 2 to the x power. Remember, we don't have an obvious a value here, but we can assume that our a is 1. So here we would have a y-intercept at 1. So I can already, if we plug 0 in, my y-intercept is at 1, so I can put a dot there. If I plug other values in, well, negative 1. If I have a negative 1 in our exponent, back. If I have a negative 1 in our exponent, that will actually make it go to the denominator. This will be 1/2. Put 1 in, 2 to the first power is 2, 2 to the second power is 4, and 2 to the third power is 8. So because this b is greater than 1, this will be growth. So I go 1, 2, 2, 4, 3, 8. This starts small and gets really big really quickly. Remember, this is kind of like going to the door. I said if we go halfway there, we'll never actually reach it. So we'll never actually reach our x-axis. Where does it cross the x-axis? Never. This will never cross our x-axis. Never. Where does it cross the y-axis? Well, that's our y-intercept right here at 1. Or if we want to do a point, 0, 1. What shape is the graph? Well, this is growth. Domain. Domain is all real numbers. I can do my symbol there. And my range is my y's that are greater than 0. Because remember, it never crosses 0, but it gets really, really close. As the independent variable increases, the dependent variable also gets bigger. It also increases. All right, here's an example in context. So this is when we're applying our exponential functions to a situation. So we have this technetium-99 is a drug taken by a patient, then used to study tumors in brain, lungs, and other parts of the body. The patient takes a 1,000 milligram pill. So we start at 1,000 milligrams here. The data below shows how much active ingredients remain in the body over 6-hour time intervals. So initially we had 1,000 milligrams in our patient's body. That would be our y-intercept, our initial value. What is the growth decay factor? Well, if we're looking, every time we go down here in our y value in our tables, our number is getting smaller. Therefore, we are decaying. Well, by how much? Well, it looks like I'm splitting this in half every time I go down. So our growth or decay factor would be decaying by 50% or 0.5. So that's what I would be multiplying by every time I go down. I could also say a half. 50% would need to be expressed as a decimal or a fraction. So a rule. I start at 1,000. That is my B factor. I'm going to or that is my A, sorry, that's my initial value. I'm going to multiply that by my B, which would be 0.5. That's how much that's my common ratio. And I have my exponent. That would be my rule for this function.